I'm building a programmable lab instrument, one that I can control from LabVIEW, and it's not that hard. There are a few things that you have to put in place. There is communication needed between the computer and the microcontroller, and I'm using USB for that. You have to understand the commands that are coming from LabVIEW, and the standard for the measurement instruments and lab instruments is SCPI. And I found a library that talks and can parse SCPI, so I'm using that. And then the third thing is taking care that your instrument knows how to react on those commands and do physical things like putting pins high or low, measure input, or generate a PWM signal. So those are the things that I'm looking for. And before we go into the details, let's just have a look at the proof of concept to see that it's working. So I have this Hercules launchpad here connected to my computer via USB. I have LabVIEW running with a serial testbed, and I am going to execute this program, and it should give us the serial number of my Hercules launchpad. It's continuously sending the IDN command and then returning the signature of my instrument. And you can see that here on the launchpad, the LED here is blinking every time we have a communication. Because this measurement instrument will have to do several things at the same time, I decided to go for a real-time operating system, and that makes it easier to handle the communication between the LabVIEW and the microcontroller and all the other things that the instrument has to do with decent time management.
We must do a few things in our firmware. First, we have to configure our project in Hercules. We will select a FreeRTOS project so that we have the FreeRTOS port generated for us by default. We'll take care that we select the correct drivers. In our case, this is serial communication interface number 2. In that module, we will define the baud rate, the stop bits and the data length. And we will also tell that we are going to use a receive interrupt, because we are going to react on every character that enters on our USB port. We have to, because we don't know upfront how many characters we'll receive from LabVIEW. We're going to set 2 ports as output, and these ports are connected to the 2 user LEDs on the launchpad. I want to use one LED to see if our operating system is healthy, so I'll implement a heartbeat that pulses every second, and we can immediately see if something is happening in the firmware that takes too much time and interrupts the operating system. And I'm using the other user LED to indicate that there is communication between LabVIEW and the microcontroller. Whenever communication starts, I will light up the LED. When the communication is finished, we'll dim it, and we have a visual clue that things are going fine. And to parse the LabVIEW commands, I'm going to use an existing library. It's the SCPI parser from Jan Breuer. It's used in many projects. I think it's the most popular C library for SCPI that's around. I've already tested it and it works excellent. And the remaining activities will be to define the operating system tasks that will take care that the input from the USB is sent to the parser and that we get replies back.
But that's food for the next video. We'll go into detail on how we configure the serial communication, how we talk to that parsing library, and how we can configure our instrument so that it knows how to reply to commands from LabVIEW.